Hydrovolt.
Thank you. And I'd like to say in advance, don't we have a good technician and hasn't he worked hard enough? Thank you. It's a pleasure to be here. It's my first time in Oregon, in Eugene rather, and I had no idea that people here were so intelligent and good looking. Thank you for this opportunity. I'd like you to look at this picture here and just think about how many places in the world look like that. They don't have turbines yet. But flowing water exists all over the world, and it's got a lot of energy in it, and we've got a solution to turn a global untapped energy resource into a new industry. Our company came from a background doing a study of tidal energy in the Tacoma Narrows of Puget Sound. And I was the director of the biggest study of tidal power ever done in the United States during 2007. I supervised 8 engineering companies and 3 University of Washington professors, and we tore up the tidal turbine space. That's where we learned about this business. We concluded that the ocean is a bad place to be an entrepreneur. It's very expensive and hazardous. And we've also realized that tides, of course, are not steady enough as a resource in order to be a good energy product. They vary over time. We found a better solution. So the problem that we're solving is that fast water currents have a lot of hydrokinetic energy. And here in the lower right picture there, you can see a graph. The power increases with the cube of the velocity. So when you double the speed, you get 8 times the power. So a small increase in velocity makes a lot more energy, and a turbine that's about the size of this desk in a velocity of about 2 meters a second can make enough power for your house. And we've developed a solution for that. The new flip wing turbine is made out of simple flat paddles with a very unique mechanical hinging mechanism. As a consequence, first of all, it's not shaped like a wing, and that means it's easy to make in a metal fabrication shop. That drops price way down. Also, it can be suspended in the flow with just 2 ropes, which means that we can drop it in and make electricity very quickly. And in fact, we're aiming for a typical installation for a hydropower at less than an hour. And as a consequence, we don't need any dams or construction, and for the target market we're after, these artificial canals, there's no permits necessary either, which is an extraordinary thing to say when you're talking about a renewable energy resource. The innovation is in the design of the machine itself. Here you're looking at the innovation of the machine side-on with plastic transparent discs suspending the blades. The blades are hinged on the outside, and the inner edge is free, and it rests against the shaft, the central shaft, as the water pushes it over. Then as the blade comes around on the upstream side, the water pressure automatically pushes it open on the back. What we've done is we've eliminated almost all of the upstream drag. So we're getting as much as 98% pressure differential across the axis. So the machine itself is easy to make. Now, of course, making underwater generators is not easy, and that's one of the ways that we're going to prevent backyard competitors from running off with our hardware. The product that we're going to be producing is a floating turbine, and this is a standard model here in the illustration because, of course, there's going to be 3 different sizes of turbines in general, and they also make a different amount of electricity depending on how fast the water goes. Remember that cube of velocity I was describing. Double the speed, get 8 times the power, so it really depends where you put it. But the unit's designed specifically to become complete in a box, and so it'll be modular, it's scalable, it's relatively simple, and the biggest one we're ever going to make is 18 feet long by 6 by 6 feet on the side, and the reason is because that way we can put it into a standard shipping container, an international shipping container, and we can airmail it anywhere. I can deliver a turbine to Antarctica by Hercules airplane. We're aiming for a 15-year lifespan on the product with an average cost of $21,000 for the mid-size machine. And the power that comes out of these simply goes up the anchor cable to a local load, and that can be a pump along the side of the canal, it can be a meter, it can be a house, it can be any number of systems, and all of the electronics are embedded in the system, so the inverters, the power conditioning, etc. is all on board, and you can have 120 volt, you can have 240 volt, you can have whatever power you want out of it. It's been a big deal to make this because in the left side here, upper left, that's how people have made water power for 4,000 years. So we've changed that business now. Not only can the turbine replace a paddle wheel, but it can actually replace the structures in the canals themselves. In the lower left, you see a check structure that's placed in the canal to allow the water to drop down as it travels. We can replace the entire system with a turbine. Instead of just having a dam, we make a renewable energy system that performs two functions, controlling the water flow and making power. We've got a large prototype that we've manufactured and put onto the Duwamish River in Seattle, and this has now been sent off to Woods Hole Oceanographic Institute. In the video here, you can see it being towed behind a boat at only 1 knot. I mean, this is even slower than you would walk down the street, and it's already making electricity. There is no other machine ever made in the water that makes electricity at that slow a current speed, and that's really huge because there are lots of slow currents, not so many fast currents, lots of slow currents, and a little bit of power in the right place can be very, very, very valuable. Now, the world is our target, but we're going to launch the business in a very safe, scalable space, which is the irrigation districts in the western USA. There are thousands of these districts, and we've done a sampling of the ones supplied by the Bureau of Reclamation's dams across the western 17 states. We've identified some 400 districts. They have about 20 miles of canals each. By the way, each district has on average between 150 and 200 miles of canals. So when we say we're looking at 20 per district, we're talking about a small fraction of the available space. And 10 turbines per mile gives us a potential market of over 80,000 units in the western USA alone. And there are much larger markets globally, of course. Here in the upper right, we have the Kennewick Irrigation District. On the center, we have Snoqualmie Pass, a canal running down to Cle Elum, and in the lower right, we have Arizona, a big canal going up to feed the city of Phoenix. And our expansion markets are global. New England water mills. Everywhere in New England and in Europe and in China and in India, where for thousands of years they had water wheels to grind grain. Now those water wheels are gone, but the water channels are still there. And it's still fast and it's still controlled. There are other industrial applications. The city of Rochester's wastewater treatment plants there on the lower right, the power plant at the bottom here. We were contacted by the Boardman power plant operated by Portland General Electric. They've got a hot water river running out the back of their plant. They want to put a turbine in there. They're waiting for me to show up. It's a little bit of a ways to drive my turbine, but we'll get there. So we'll be selling these renewable energy generators in the $10,000 to $15,000 range with 3 standard sizes, using a distributed manufacturing model, because most of the machine is steel and there's no point in moving steel around the world. You can make most of the machine in a local shop, and then we send them the high-end electronics and the generators. And as a dealership partner, we've got a great opportunity. The same people who sell pumps understand rotating machinery in water. And so we're already hooked up with the biggest pump distributor in Western Washington, Pump Tech of Bellevue, and they're excited about carrying our product in their catalog. They say, well, you can put the turbine in next to our pump and you can provide the power to our pump. We'll sell them for you. And the great thing is, there are distributors of pumps across the entire planet. It's a truly global product. They're in India, they're in Africa, they're everywhere are pumps and people who can maintain and sell our product. We do have some competitors, but they're a little different. In the lower left here, we have New Energy Limited from Canada. Their turbine is a vertical axis device that spins like so. 3 times the cost and very limited its application. Verdant Power putting turbines into the East River. That machine's 20 feet tall and it cost them $5 million just to get wet. Another company going into a big river in Minnesota, but again, these are huge machines. They have very limited markets. They cannot get to mass production because there's just not enough opportunities out there. We have great traction so far. We have been winning a number of contests. We were finalists in the Clean Tech Open, and we were the winners of the National Sustainability Award from the Clean Tech Open out of 230 companies. And because sustainability means sharing your best practices, we've put the chapter of our sustainability plan from our business plan online on the Hydrovolts website. So if you want to download an award-winning business sustainability plan, please visit our website. We have partnerships with the University of Washington Mechanical Engineering Department. I have 25 students over there in the last 2 years who worked on our machine with us. They love it. Woods Hole Oceanographic Institution and the U.S. Navy are also R&D partners. We had inquiries from 16 countries. I get them about twice a week. I got a guy in Bolivia that wants 47 units right away because they have no grid. They get power from bringing diesel in by Jeep or donkey. We also have new investors, and I'm happy to say that this Willamette conference is paying off for us. There's somebody here in the audience who I met at lunch who's excited to talk to us, so thank you. We have a great team too. I've got 30 years in marine technology background, international development. I've been a clean tech consultant to the UN and to USAID for over 15 years. My business partner was an early employee at Microsoft and has been the CEO of an electronics company for the last 7 years. A great team of engineering and operations folks from the Navy. And as advisors, we have folks that are working not only on marine engineering, but water pump sales, and also canal design. CH2 and Hill, the big engineering company, is working with us now. We expect to have a hockey stick of growth, and I want to point out to you the number here in unit sales in the lower right of 10,000 units at 2014. Remember, I talked about the Western USA, 80,000 potential units just in that space. We're looking at 10,000 to hit all of our revenue targets. We're raising $500,000 on a $1 million pre-valuation. We've been living on air in 2009. It's been a long year. And so we're looking forward to raising more funds to complete our prototypes, to getting our demonstration projects in the water, patents, and then avoiding dilution by using grants from large companies. We're in talks with Siemens already about potential venture acquisitions. And we're looking forward to changing the way you look at water. I hope that from the rest of your life, you'll never look at a fast-flowing water stream without thinking, where's the turbine? Where's that turbine? Thank you very much.